Hey guys, welcome back. Another week, semester's coming to a close, so all positive things. Let's stay strong and finish strong here, okay? Like always, I've got some vocabulary, very important. If you haven't picked up, these are very quick points on any quiz exam, so it's worth your time to pause the video here, jot these down, and get familiar with them, okay? What I am going to say here is a couple of things that will tie in where we've covered recently to what we're covering today. Alright, and just so you know, we are on chapter 7.6, and that is the natural number E. Okay, so let me just cover some prior knowledge here. Okay, we talked about inverse properties of logarithms and exponentials in particular. Right, we said that if you have, or if you take the log base b of x, right, these matching bases cancel, you're left with x. At the same time, you can introduce a base b to the log base b of x, and that too, because these are inverse equations or functions, they cancel out and you're left with x. Okay, again, this is the inverse properties of logarithms and exponentials. Okay, this is review. Now, something else that's a review that we really haven't highlighted is this concept of the common logarithm. Right? If I've got log, I don't know, log of x equals y. Okay, we do implied here because there's an invisible base, right? Or at least it's not visible, so therefore it's implied that it's a base 10, and we did talk about that. This here, this has a name, okay, since this guy's so popular, log base 10, so much so that we don't even write the base. Okay, it's implied. We call this the common logarithm, or the common log. Okay, alright. So, going into today's lesson, we now have log base e of x equals y. Okay. So you're wondering, okay, what's the difference here? Well, e, in case you have forgotten, it's an irrational number. It's a number, just like 10 is a number. However, he's got his own special properties. So, in this case, if you have log base e of x equals y, which is still along the lines of the same logarithm properties that we've been discussing, okay, this is another common log. Okay, it's used very frequently, but it would not help us to call it, to have it the same name. So we call this, because this is the natural number e. Okay, we're gonna call this the natural log, and the way it's abbreviated, kind of like this guy has his abbreviation, it's ln, okay, for the natural log of x equals y. So, long story short, when you see natural log written like this, it really means log base e. Okay? Alright, let's move forward here. Okay, graph e raised to the x plus 2. Let's go and do that. Shouldn't be too hard. So I'm going to go here, e raised to the x plus 2. Let's see what that graph looks like. Alright, there we go. And of course, if you're asked to provide an image, you can just draw it out, but you do want to pay attention. Let me go and make a comment here. Okay, that essentially the parent function e to the x looks like this. This plus 2, the way it's done in the past, it is a vertical shift, so you'll notice that it's been shifted up twice. So again, you're highly encouraged to play with e to the x and do different funky things to it, but that's just the basics. Okay. Alright. Simplify the natural log of e raised to the negative 5x. Alright. So whenever you're iffy, it's always good to kind of rewrite the problem, remind yourself you know how to write, you got some math skills. Alright, so then what do we do here? Well, since this is new to you, natural log, you look back at your notes and you do know you can rewrite this as the log base e of e to the negative 5x. You'll notice here that although it might be a little unfamiliar to you, we do have matching bases. They do cancel. And let's see here, we're left with negative 5x. Let's see, I'm having issues with my writing pad here. Negative 5x. Alright, so there's not much more to that needs to be said beyond that. Okay, we'll look at the very similar problems in class. Let's go ahead and move on to this problem. Nadab invests $6,000 in an account that earns 5% interest compounded continuously. What is the total amount of her investment after 8 years? Run your answer to the nearest cent. Alright. So a problem like this should be familiar from different contexts in your past. Okay, all these interest and interest in nature type problems. The formula that is appropriate here is A equals, they call it the A-PERT formula. A equals P E and it's raised to the exponent RT. Okay. So let's simply start plugging in here. So as far as A, alright, that's going to be the amount that's going to, or specifically, it's going to be a total amount of her investment after 8 years. Okay, so that's A. P is going to be what, that principal, that initial amount, so the 6,000. E again is a number. You know, the instinct is to think of it as a variable just because it's a letter, but it is a number, so get that, kind of like pi. Alright. Anyways, what else are we missing here? We need the rate. So we'll put 0.05, which is the right coming from that 5%. And what else do they give us? They give us t, which is 8, and t is measured in years as a unit. Alright. So what else needs to be done here? Pretty much a calculator, right? So let's go and do that here. 6,000. So I'm going to hit this button there. Hit E. Take a quick peek here, and it's 0.5 and 8. Alright. Just exactly how we had our problem set up, and we got 89, 50, 95. Okay. 9, 50, 95. Okay. And that answers the question, what is the total amount of her investment after 8 years? This is it right there. Alright. This next problem reads, radioactive iodine treatment is so successful at treating hyperthyroidism that it has virtually replaced thyroid surgery. To the nearest full day, determine how long it will take for 400 millicalories of I-131, which has a half-life of 8 days, to decay to 3.125 millicalories. Okay, a problem like this is going to require a formula. So let's go ahead and provide that here. N sub t equals N sub 0 E raised to the negative kt. Okay. So it's an intense kind of problem, but really it gives you an opportunity to for the application, right, of a story problem that involves this natural number e. Okay, so it fits right in this context. Alright, so we're going to go and plug in here. What we're going to do is we're ultimately going to, like we've done similar problems, like direct and indirect variation, things, problems of that sort. We're going to first solve for the natural decay, or excuse me, the decay constant k. Alright, so let's go and plug in here. N sub t, okay, we're dealing with the half-life. Initially we got 1, or the full amount. So I guess since I'm substituting from the problem, I'll put in parentheses. We got E again, not a variable, very much a number. We've got negative k. Okay, we don't know what k is, but as far as t is concerned, we do have 8. Okay. Right. So 8 days coming from right there. Alright. So what we can go ahead and do is kind of solve this bad boy. So let's go and clean this up. So we've got half equals e negative 8k. Alright. Now the next thing we can do here, okay, and this is from the notes we just provided earlier, is we do want this exponent to kind of come down here as a regular script, right? So we can kind of get at that k. So the one thing that I'm going to apply here immediately is the natural log half of half, right? I'm going to take the natural log of both sides, negative 8k. Okay, so I'm taking the natural log of both sides. Now some of you guys got this and some of you guys are a little might feel a little awkward, so what I'm going to do here is, just for you guys' benefit, is I'm going to rewrite the natural log as the log base e of half, the log base e of base e raised to the negative 8k. So as you can see now, I took the natural log of both sides for the sole purpose of what? Having it cancel here. Okay, so I'm going to go back and rewrite this as the natural log. So now I have the natural log. Give me a second here. The natural log of half equals what? This part cancels and I've got negative 8k. So then the obvious thing here would be to divide by negative 8, and now I have k equals to the natural log of half over negative 8. Okay, so let's go ahead and punch that in the calculator, see what that gives us. Natural log of half over negative 8. Alright, so see here ln in blue, I'm going to hit Control e to the x and take a quick peek. Natural log of half 1 divided by 2, and come out here, and whatever I get there I'm going to divide it by negative 8. Negative 8, that's right. And I got 0.086643. Whoops. Okay. 0.86643. Alright, so that means I now have my decay constant k. Okay. Right. Let's go ahead and continue here. I'm going to do a semi-page break, okay, kind of like that other symbol that we have for a page break, except with one dash going down. Okay, it's not a full, complete new thought. Okay, there's some continuity here. Alright, so now we're going to go and write the decay function and see if we can solve for t so we can ultimately solve the problem. Again, how long will it take basically for this amount of I-131 to decay to that amount? Okay, so now we're going to get into the specifics now that we have our decay constant. Alright, so let's reintroduce the formula. N sub t equals n sub 0 e, and we're going to go and put in the number we got, 0.86643. Okay, that's our decay constant amount right there. And over here we're going to put t. Now as far as with the storyline problem, this is what we're concerned about it decaying into. Okay, since I'm substituting, I'll go and put parentheses. We got that initial amount. We got e. And we've got this exponent up here, 6643. Our decay constant times time. Alright, so now as you can see, we're going to solve for time to answer this question. So the first thing we can do is what? Excuse me. Alright, if you're thinking divide by 400, that would be a good instinct. And I'll tell you what, I'm gonna come down here. I'm gonna skip actually writing the division. Well, I'll tell you what, let's just make it obvious here. No shame in writing out all the steps. Okay, so obviously it's going to cancel out on this side. Let's see what we get here. 3.125 over 400. 3.125 divided by 400. 0.007813. Okay, equals E 0.08663 times T. And now comes the cool part. Hopefully by now you're a little more comfortable. I'm going to take the natural log of both sides. 0.007813 equals the natural log of E 0.08663 times T. Okay. Now this time I'm not going to write in log base E. If you'd like to, you can do it for your notes. I'm simply going to maintain this notation. 7813 equals, right, this will cancel, so I'm left with negative 0.08663 T. Alright. And what's the next thing to do? Again, we're trying to solve for T here, so we can simply divide by this value here, and because it is so lengthy, I might as well just set it up here. Negative 0.08663, negative 0.08663. It'll cancel, ultimately leaving us T. So let's go ahead and put that in here. Okay. All right. 0.07813. Oh, 0.07813, got it. Let me pop out here, divided by 0.086643. 0.086643, and we're left with 55.9, which is roughly 56. So we'll do one of these, equivalent to about 56. Whoops. Having trouble writing here again. So roughly 56 days. 56 days was the unit for that problem. Alright, appreciate your patience there. Let's go and move on to the last one. This was kind of a vague request. Write the expression, what expression is equal to log of 50. Okay, that's really how you read it. Again, I'm not saying in log base 10 of 50, but that's implied. So as a refresher, what I'm going to suggest here is to use the change of base formula. Okay, let me see if we can write it out here. I'll put a little star, right? Log base b of x, right? Change of base tells you that you can go log of x over log of b. And here I'll put a little box. Remember in the notes you guys had an a because you can really put any value that you want in there that is appropriate. Okay, that works. So with that said, let me do a little page break here. Here's essentially what we can do here. We can go log of 50 equals what? Log base 10 of 50, right? Because the 10 is implied, which is log. I'll tell you what. Since we're working with the natural log, instead of sticking to that gun, let's go ahead and do this. Okay, check this out. I'm going to go log of 50. I'll go a little slow so I don't miss anybody here. Log of 10, and why not? Okay, let's use e since we're working with it, and that'll give us what? The natural log of 50 over the natural log of 10. Okay. What else can we do with that? Let's go one step further here. We can go and write this as the natural log of 50 divided by the natural log of 10. Alright, and this will be the form that we'll stop at. Notice that it's in the form of a natural log. Alright guys, appreciate your time. I'll see you in class with questions, comments, and concerns.